This is Algebra 2 with trig, 8B.3b. We're looking for some patterns that you might see in the unit circle. In previous lessons, we have filled out a unit circle. This is one example of us filling out a unit circle. And things that we're going to recognize is that some of the radians have a 4 for the denominator every time. And when you have a 4 for the denominator, you're going to have the same coordinate every time. Root 2 over 2, root 2 over 2. The only thing that's changing is sometimes they're positive and sometimes they're negative. Then we're going to look at what happens when the denominator is 3. There's one in every quadrant that has a 4 in it. There's one in every quadrant that has a 3 in it. If it's a 3, all the coordinates are exactly the same. They're all a short x value and a long y value. So a half in root 3 over 2. So we'll talk about what radians have a denominator of 4. Well, from what we just looked at, we had pi over 4. Now if we were to count and do pi over 4, 2 pi over 4, that gets reduced. That no longer has a denominator of 4. 3 pi over 4, 45 degrees again is going to be 4 pi over 4. That gets reduced, so it doesn't have a denominator anymore of 4. 5 pi over 4. 6 pi over 4 got reduced. 7 pi over 4. And then we could finish up with 8 pi over 4, and that's considered 2 pi, and of course that's reduced from 8 pi over 4. So those are all the radians that have a denominator of 4. What are their equivalent degree values? They're all 45 degrees from the x-axis. So we're thinking here that if you have a denominator of 4, you're 45 degrees from the x-axis. You're 45 degrees more, which happens to be 45 degrees from the x-axis. And then from the x-axis, you're 45 degrees more and 45 degrees more, which is 45 degrees from the x-axis. So this is 45 degrees. We didn't do the 90 because that would have been 2 pi over 4. We moved on to 3 pi over 4, which was 135. We didn't do 4 pi over 4 because that was reduced out. Now we're at 225 and 315. All of these are 45 degrees from the x-axis. The ordered pair. What are their ordered pairs in each of these? You can look right on your unit circle, and you'll notice that all of these have root 2 over 2. They're all over the same amount, up the same amount. So at 45, we're going to have root 2 over 2 and root 2 over 2. But when we move into the second quadrant, we're going to have to go left first. We're going to have a negative x, but a positive y. Then to move down into the third quadrant for where 225 is, that's going to be a negative root 2 over 2 and a positive, and another negative because it's down. And then the fourth quadrant is going to have a positive x and a negative y. You can verify all of those coordinates right on your unit circle. They're over and up. In each case, this is to the left, so it's negative x but positive y, negative x and a negative y, a positive x and a negative y. You can pause the video, try to fill out any denominators with a 3. Those are all the ones 60 degrees from the x-axis. What are the equivalent degree values? What are the ordered pairs? Can you do it without your unit circle? Can you recognize and do the counting in your head? Or you can look at your unit circle to be sure that you're pulling out the right values. So with a denominator of 3, that's going to be pi over 3. 2 pi over 3, that cannot be reduced. But 3 pi over 3 can be reduced. Then there's 4 pi over 3 and 5 pi over 3. But 6 pi over 3 is a full 2 pi, and that's reduced. So these are the only radian values with the denominator of 3. This one's going to be at 60 degrees. That's pi over 3. 2 pi over 3 is going to be 60 more degrees, which is 120. Now we're skipping 3 pi over 3, which is 60 more, which is 180. So then we go to 4 pi over 3, which is 60 more, which is 240. And 30 more, which is, or 60 more, which is 300. Their coordinates. If you think about their coordinates, if you want to think about it as a first quadrant, and you're not going to just use your unit circle, you're doing a visual. We're up here at pi over 3 or 60 degrees. You're moving over a short distance, but you're going up a long distance. So the coordinate's going to be a half root 3 over 2. Because the short is your x value, and the larger number is your y value. So being in the second quadrant, your x is negative, but your y is positive. In the third quadrant, your x is negative and your y is negative. And in the fourth quadrant, your x is positive, but your y is negative. You can verify all of those on your unit circle. At pi over 3, you know what your coordinate is. At 2 pi over 3, that's 60 more degrees. That's going to be negative to the left, positive going up. We didn't talk about 3 pi over 3 because that put us right here. And 4 pi over 3, 5 pi over 3, and would be equivalent to 6 pi over 3. If you haven't already done so, move on to do the sixths. We have pi over 6, 2 pi over 6, but the 2 and the 6 can be reduced, so we don't count that one. 3 pi over 6, we don't count that one. 4 pi over 6, 5 pi over 6, 7 pi over 6, 8 pi over 6 we reduce, 9 pi over 6 we can reduce, 10 pi over 6 we can reduce, and then we're finally to 11 pi over 6. If you were looking at your unit circle, you would have seen that we're at 6, gives you a 30-degree angle. We reduced to get to here, we reduced to get to there, we reduced, But when we were back over to 30 degrees from the x-axis, we had another denominator of 6. 30 degrees from the x-axis gave us another denominator of 6. But any other amount gave us a different denominator. 30 degrees from the x-axis gives us a denominator of 6. So we're at 30 degrees, 150 degrees, 210 degrees, and 330. The ordered pair, you're over a long way and you're up a short way to get into that 30-degree location. So we're at negative root 3 over 2 and a positive half, negative root 3 over 2, and a negative half, because now we're in the third quadrant. And in the fourth quadrant, the x would be positive, but the y would still be negative. You can verify that right on your unit circle, that all of these have the same values, just the signs are a little different. So what we've talked about, all the radian measures with the denominator 4 have degree values, degree measurements that are 45 degrees from the x-axis. You could also say that they're multiples of 45 degrees. I'm not sure what that's going to do for us, but they're 45 degrees from the x-axis. That's going to be an important information in the future. Ordered pairs are always root 2 over 2 and root 2 over 2. The only thing that changes is by a plus or minus. You could call it that, or you could call it, the only thing that changes is the sign. Denominators of 3 are 60 degrees from the x-axis. They are all multiples of 60 degrees. That's going to be a half root 3 over 2. You're over a short way and you're up a long way to get up to the 60-degree marker. The only thing that changes is the plus or minus, or the sign. The 60, or the 6 actually, they're all 30 degrees from the x-axis. They're ordered pairs. It's going to be a long way over and a short way up to get up to the 30 degrees. So the long way over is the bigger number and the shorter number. And as you move around the circle, the only thing that changes is the plus or minus. It's the sign. Now, we don't want to use the conversion factor when we're switching from degrees to radian. If you have to look on your unit circle, that's one method, but we even want to try to start to do some visualizing. Here we have 225. Where is 225? Well, 225 is greater than 180. By how many degrees? By 45 degrees. So I know that this is multiples of the 45, multiples of the pi over 4. So then we would have had 2 pi over 4 and 3 pi over 4. This over here would have been 4 pi over 4. So that makes this one 5 pi over 4. I wouldn't consider this to be something that we're memorizing, but we're learning how to count it. We're learning what it means. You can count your way around to figure out what these radian values are. 120. 120 degrees is going to be 60 and 60 again. It's 60 degrees from the x-axis. You can compare that to the 180. It's 60 degrees from the x-axis, so it's going to have the same relationship as we did over here. So this is pi over 3. This is going to be 2 pi over 3. That's the radian version. We did not use a conversion factor. We didn't use our calculators. We actually didn't even use a unit circle. We used the idea of what we know about the unit circle. If we have radian, what is the degree value? Well, think about your unit circle. 11 pi over 6. Well, this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5, 6, 7, 8, 9 pi over 6, 10 pi over 6. There is your 11 pi over 6. That is 30 degrees from the x-axis. So it's 30 degrees less than 360. That's 330 degrees. 3 pi over 4, that has a 4 in it again. We've already been here. So here we have 1 over 4, 2 over 4, and here we would have the 3 pi over 4. It ends with a 4 in the denominator. So 45 more is 90, 45 more is 135. We could do that without a conversion factor, even without looking on our unit circle. Find the measure of the angle determined by the endpoints of our terminal side on the unit circle. We want it in both degrees and radian. So, visually, in your mind, you're thinking of a negative x, you're moving to the left, but a positive y value. Notice how both the x and the y have the same value. So you know that this is multiples of 45. If we have root 2 over 2, we know we are multiples of 45. So this is going to be 135 degrees, otherwise known as 3 pi over 4, as we have drawn out earlier. One comma 0. Well, that's coming straight across. Of course, that's going to be 0 degrees, but we would typically call that 360 or 2 pi. But it would also be 0 degrees and 0 pi. Either way you want to think about it. It looks like up here, by the way that they're using their notation, they don't want you to use 360. They want you to use 0. But it's also true for 360. All right, here's a tougher one. So we're thinking about a unit circle. This is half, negative a half. So we're going over a short distance. And then we're coming down a long distance. So in this situation, we are 60 degrees away from the x-axis. So we know we're 60 more degrees than 180. So we know this is 240. 60 works with 180. It goes in there 3 times. So we have pi over 3. we have 2 pi over 3, 3 pi over 3, and this would be 4 pi over 3. That would be equivalent. Now we finish up with evaluate. Again, we're thinking about a unit circle. Remember, when we do these, an ordered pair is always cosine and then sine. And tangent is always the sine over cosine, otherwise known as y over x. So what is sine of 0? So you need to know your coordinate at 0 degrees. That's going to be 1, 0. The y value so at 0 degrees, we get 0. At 210 degrees, that's 30 degrees past the x-axis. This coordinate would be long, short. The cosine is going to be your x value, so it's going to be negative root 3 over 2. Notice we did not use a calculator. We do not use decimals. Tangent. Tangent of 180. 180 over here is to the left 0 and up, or to the left 1 and up 0. So tangent is 0 over negative 1, which is 0. Sine of 2 pi over 3. Well, you need to identify where 2 pi over 3 is located. 1 pi over 3 was at 60 degrees. 2 pi over 3 is at 60 more degrees. So you're up far, but you're over a little. So that's using, you're over a little, so negative a half. We're up far, which is our y value. So that is root 3 over 2. All right, 2 more. 7 pi over 4, that's almost 8 pi over 4. So I know I'm down here in this 4th quadrant. I know it's root 2 over 2, negative root 2 over 2. We want the cosine, which is the x value, so it's root 2 over 2. And then to finish up, this is tangent of 11 pi over 6. That is almost 12 pi over 6. That's almost 2 pi. So this is root 3 over 2, but down a half. So we're going to do our y over our x. And to do that, we need to multiply by the reciprocal. That gives you negative 1 over root 3. And when you rationalize that, you get root 3 over 3.